technical design project was a compartment syndrome diagnostic cuff. Compartment syndrome is a condition that often affects runners and leads to a buildup of pressure in the calf, which leads to because of a swelling in the tissues. It often causes pain, discomfort, and a tingling sensation, like when your foot falls asleep in that area. One problem that's caused by compartment syndrome is that it has a severely invasive diagnosis process. It typically involves sticking a long needle into all of the compartments of the calf after the patient has undergone at least a 2 mile long run. Our proof of concept will resolve this problem by easing the physician's diagnosis process and alleviating the stress and pain that patients often feel. On the left, we have an image of kind of the inside of the calf, so you can see just how many different compartments there truly are and how invasive this process really is. So we need a way in order to non-invasively measure the internal pressures of the calf in adult runners that are aged 18 to 35 in order to diagnose this compartment syndrome.
So for code operation, first, of course, we have to set up the LCD. And then after that, we're going to read from the instrumentational amplifier. And then we're going to map that to create our force, or to measure our force. And then we're setting an integer called threshold, and that can change from patient to patient. It's just our comparison factor with the force. So if the force is greater than the threshold integer, we have our buzzer ring, which indicates that the patient has compartment syndrome, and if it doesn't ring, the patient's not diagnosed with compartment syndrome.
Next, we have a layout, the concept image of our product. So first, we have the cuff and the embedded force system, which is right over here. This sits along a 3D printed part, which evenly distributes the force across the entire cuff. Then coming out of the force sensor, we have these wires that will in turn connect to our LCD screen, which our LCD screen will display the force exerted inside the cuff, which will allow us to take into account its content.
So inside of our LCD screen, we have this circuit diagram, which will hopefully shrink down in our final project. And so on this side of our circuit, we have the LCD screen set up with the potentiometer, changing the contrast of the LCD screen. And on the other side, we have the stuff with our force sensor. So in here, we're looking at small differences in forces because the calf doesn't apply a huge force. So we have a Wheatstone bridge, which the force sensor is a part of, and 10K resistors going into an instrumentational amplifier. And the output from the instrumentational amplifier goes into the Arduino and then is read by the code. And now we have the showcase of our prototype.
First, the patient will run until they start to feel tingling and numbness in their feet. Then they will wear a compression sleeve, which has an embedded force sensor and a part that allows for even force over the sensor. The force sensor measures the external forces of the calf. The force is then written onto the LCD, and the buzzer buzzes if the force is higher than the threshold for compartment syndrome.